And what would happen if that is the case? Well, what would happen with LED if this is a 1? Goes on, right? So, if I'm able to write a 1 on that bit with software, if that happens that LED is connected to that bit, it could turn on. Of course, it has to go in series with a resistor. I'm assuming you guys have seen that somewhere, or not yet? Yeah, because of the characteristic of the diode, but we can discuss it.
If you've taken 1400 already, yes.
Yeah.
If not, no.
Yeah. Whereas if I write a 0, it will turn off, right? There are ways of using inverted logic if it's effective high or low, but that doesn't matter. We're trying to simplify it. I could also have another bit that is maybe connected to a switch, right? Whereas this switch could be, I don't know, this could be connected to a resistor here, and this switch could be connected to 3 volts. In a way that when I close the switch, this thing goes high. So now this bit is no longer controlled by the software, it's controlled by the hardware, in this case the battery, right? And the software should be able to determine and read and see if that bit is either high or low, okay? And it could do something, it could respond to that button press. This is what this course is about, in very simple terms. It's about everything being here in the memory, having an address. In some location, I will have these ports, and these ports connect to the hardware as well as the software, okay? And they can both interact. Questions up to this point? Okay, so I'm going to try to erase not so much.
Oh, wait.
So maybe I'll roll this one up so I can actually this side.
I understand the panic.
All right. So let's do the exercise again with my port A. Now, I haven't yet talked about this, but how do I do an AND in code? In C. Ampersand, right? Is it 1 ampersand or 2 ampersands?
Are you looking for a logical and or a bitwise?
I'm looking for a bitwise at this point, right? So it's 1. For the OR,
Just one line.
this one, right? For this exclusive OR, this guy.
Caret.
This guy is not powered. Please. Yeah, we need to stress that.
Caret.
This is my port A, okay? And again, I'm simplifying this whole thing. The ports in this micro are 32 and 16 bits, but I just want to make it 8 bits so we can make it simple, okay? Enough. And this will be my bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. Now, first example. I want to set B2, everything else unaffected. How can I accomplish that? Let's assume that my variable port A is the one that controls that port, right? So I'm just gonna call it port A. If I do this, port A equals port A and then I write this, this is how you write a number in binary in C. So the goal is to set the bit 2. Now, how do I set? With an OR. In order to guarantee a 1, I need a 1 on the bit 2. So I'm going to write all the bits here. 1, 2, 3, 4, 5, 6, 7, 8. Bit 0, bit 1, bit 2. This one needs to be a 1. If I do, sorry, no, sorry.
It's gotta be OR.
OR. Now, if I OR this port with this number, let's do it. 0, 0, 0, 0, 0, 1, 0, 0. And when I do the OR, it goes bit by bit. Okay? So when I OR with 0, it doesn't matter. Whatever it's in here will remain the same, will remain unaffected. Whereas this one does not matter what value I have here, it will become a 1. So that's how I set a bit. Okay? Questions? Oh, semicolon. Now, there's a short version of this, which is the one that we're going to be using moving forward. I just did this one so everybody could follow. But in reality, we're going to do this. I'm assuming that you guys are familiarized with this notation, the assignment operator from C#, right? It's the same idea. When you were doing a plus equal, so basically you're reassigning to the same variable. So this is absolutely equivalent to this. Okay?
Yes, Rex.
Okay. Now, we know how to set. Example 2. Everything else remain unaffected. I'm not going to repeat that because that's assumed from this point on, okay? Everything else has to remain unaffected. Example 2. Clear. We can erase this if you want to try it here. A different bit, right? So we make it more fun. Clear B5. You want to do it? Yeah, because at this point I'm looking for volunteers. Yeah, because me talking here, everybody starts falling asleep. That's not fun. You guys better. You volunteer? Okay. And then if you struggle a little bit, someone else can come and join you and try to help you. So the goal here is to clear the bit 5, nothing else. Huh? Yeah,
I remember that, but I don't remember this.
we went too fast.
I like the wizard now, actually.
Oh, but try to do it here, Carl. So it kind of follows the same. Yeah, so we got space for the next one. Zero B, it has to be 0B because that's the notation for binary in well, the other ones have to remain unaffected. And then you gotta go to your cheat sheet here. For the clear, what is a guarantee clear? 0. What is an unaffected? 1.
I think it'd be easier to just use truth table instead of
Well, you guys are actually going faster than the other section.
I know.
Good.
The other section to take a bit more to get it. Yeah, excellent. How many you have? 3. Oh, I think you got one too many.
You have B -1 there.
Sorry. 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5. Yeah, excellent. Great. Now, look, you pick who comes next.
Okay.
Okay, but before that, just hold it there. Hold it. See what he did here. So he put a 0 on the bit 5, which is the one that he wants to clear, and everything else has to remain unaffected. So everything else has to be a 1. Okay? If you were to put any 0 anywhere else, then you also clear that bit. And if you do an equal here, it's even worse because you write the entire thing into the board.
Nice.
You don't want that. Okay? There you go.
Okay.
Like, wait.
Oh, the next
What was
class
the next
is
one?
example 3, toggle. Oh yeah, because you did it yesterday, that's why you asking, right?
Yeah.
Toggle beats,
Do I just do it anyways? Like,
what
You
do
have an
wanna do it or
advantage.
you wanna pick someone else?
I mean, I already know that.
Okay, toggle B3.
He must feel like a big man.
Do it. See, this would have been fun last time.
Right, and then power.
Which is not power.
Correct. That's right.
Yeah. Guys, help me out.
You're in the right track.
0, bravo.
B3, right?
Mhm.
So like, I already know it's like. Wait.
Excellent. Yeah.
That's you.
No, that's good, that's good, yeah. Okay, see, if you want to toggle B3, 0, 1, 2, 3, you exclusive OR with a 1, so it toggles. You want everything else to remain unaffected, everything else has to be toggled with a, exclusive OR with a 0. Okay? Questions?
So let's say we already had like a value in there.
Whatever value, yeah.
0, 1, 1, 0, 1, 0, 0, 1 or something. That should work regardless. So if I just any of those bits, as long as I stick with this cheat sheet, it will perform the function and do the
Yeah.
thing.
That is the whole point, so the other things remain unaffected.
Okay, perfect.
Now here's a tricky question. If you want to clear, which one is clear? This one. If you want to clear this bit, and it's already cleared, nothing is going to change. It's going to remain clear.
Okay.
Right? It's like, assuming that, maybe it's a bad example, but if you have one of the switches in your room that is sort of like a toggle switch, but then it's like this, so you turn it off like that, and then you turn it off again, nothing happens.
Yeah, it can't be more off.
Yeah, but there are some that are pushed, some buttons that are pushed in like this one, right? So for that one, the logic doesn't quite work because it toggles automatically from on and off, right?
Okay.
It's the flick switch.
Yeah. All right. So now what we're gonna do, and you should try this on the computer. We're gonna verify all this with code. Okay. And the way I did this, you guys should be able to see already a demo, because I think I have a demo from last night. Yeah, the bitwise demo. So if you pull the changes, you should be able to see this bitwise demo. It's demo 5. And I'm going to turn on this again. All right. So let's take a look at this for a moment. So the first question I did to the other class, how can I guarantee that I create a variable that is 8 bits? Well, how can you test that actually port A is 8 bits? Well, the chart uses 8 bits, right? But if you didn't know, how could you verify it? You have the tools already to do that. With what we have discussed up to this point. In class.
Something of.
What can I use to know the size? There. How can I give the answer? Size of, right? So if I were to print the size of, will tell me if it's 1, means that it's 1 byte, means that it's 8 bits. But for now, I guess you could trust me, this is definitely 8 bits. Okay? So the port has that initialization. When you write it in binary, later on we're going to try to stay away from binary. For now, since we're just trying to demonstrate the foundation, so later on we're going to be using masks and hex, right? But for now, the binary helps us see what's going on. The problem with the binary is that it's very easy to make a mistake when you write like too many zeros or too many ones and then you go 9 bits instead of 8. That breaks the whole thing, right? So you gotta make sure you have exactly 8 bits. So the port is initialized to whatever random value, and then I wanna set the bit 5, right? And we're gonna verify that. How can we verify? How can we verify that that happens? Any ideas? We've also done this in class already. How can I verify that the variable port A changes the way I expect it to change? Using the debugger, right? So what I did there, I put a breakpoint, right? So I'm going to put a breakpoint that stops there, okay? And I'm going to run this code. And look at the port A is already here. If you don't see this, if you don't see the variable, you want to do view watch, and then you select your watch 1. And in here, let's assume that that's not even, can I actually delete that? Yeah. So let's go from scratch here, because you guys may not have the whole thing. You go view watch 1. So that brings up the watch window. What is the watch window? It's for watching the variables, okay? So how can I add that variable? All I have to do is just copy the name and then say right click here. Well, not even right click, just try to click inside an expression and paste it there. Now that is telling me memory read failure. Well, yeah, because this thing is not yet, I haven't yet pressed play. If I press play, the program is going to stop there, and I'm going to have a value on port A. Press play, and port A has the value C2. It's obviously showing me that in hex, right? How can I verify that is effectively C2? Well, I could display it in binary, and that would work. But we should somehow get more familiarized from going from binary to hex and vice versa, and I think I stressed maybe not enough that in 1550. The way you want to do this, you want to group them in nibbles. So I got 1100, and then on the other half I have 0010. What is this number? 2, right? 2 in decimal hex, doesn't matter. What is this one? What is in decimal? This one. Louder. Somebody said it, right? 12. Excellent. That's 12. But it has to be in hex. Well, 9, 10, 11, 12. So that is correct. Okay? I'm going to change it to binary, so we can easily check. So, pay special attention to what's going to happen here. So my bit 6 and 7 are 1. My bit 0 right now is 0. If I press F10, I'm going to step over the line, and you're going to see how the bit 5 becomes a 1. See? Nothing else gets affected. You step over with F10, in case you're wondering. Nothing else gets affected. Okay? Then the next line is going to clear the bit 3. But unfortunately, the bit 3 is already cleared. So it's already at 0, so you won't see any change there. But the most important thing is nothing else is going to get affected. So everything else is going to remain the same. And in fact, it went from red to black, and when a variable shows in black, means that it's not changing. When it shows in red, means that it did change. Okay. Now, the comment is wrong here because I made a change. Yes, this is toggling bit 7, but it's doing something else. Can anybody tell me what it's doing this line?
It's shifting.
No, it's not be shifted. Be shifted is the other notation. It's toggling bit 7, right? Because it has a 1 on the bit 7. But there's another one. Where? 0. So what is it doing with the bit 0? It's also toggling. So I could toggle more than one bit, as long as I have a 1 on the bit I want to toggle, and zeros on the bits I don't want to toggle. I want to remain unaffected. So this line is not really toggling just bit 7, it's toggling bit 7 and bit 0. Okay? Now, if we press F10, now this is being done now in a loop, right? So it's in an infinite loop. While 1 is always true, because 1 is different than 0, right? So that's going to execute indefinitely. But I'm just going to do F10, 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 so I can see it one at a time. Okay? So when I press F10, pay special attention. Bit 7 is 1, bit 0 is 0. So they should flip. That's exactly what happens. And if I do it again, they flip again, and then there we go. So now if these bits were connected to two different LEDs, the LEDs will be going on and off, alternating, because one is on, the other one is off, right? So right now, bit 0 is 1, bit 7 is 0, but if I toggle again, then now bit 7 is 1 and bit 0 is 0, okay, and so on. Okay? Questions? I see a few faces that are a bit.
Can you go back and start back with the view?
Huh? One more.
When you started like to display that expression and value, like can you go back and start from there?
To start from where?
From view, like
Oh, now how to display this window? Okay, so let's say I remove this thing and I close this window. You probably don't see, you see globals only. In the globals you will see some stuff. But if you want to debug and watch your variables, you go View, Watch, and you can select Watch 1. You can have multiple watch windows. That's why you have Watch 1, Watch 2, Watch 3. I'm going to enable Watch 1. And then you need to click in the expression fields, and you need to add your variable you want to watch, for A. You type, and by default it shows in hex, but you can show it in decimal if you want. For now, it's very useful to see it in hexadecimal, right? And you right-click to change it from. You can even change the variables from here. You can increment it. See? And that is the debugger changing the variable. And now if I do this with the toggle, everything changes. It doesn't show? Let me see. You need to click in here. And you need to type forward A. Yeah. Yeah, enter. And then maybe
That's confusing. When I double clicked on demo 4, it pulled up something different. But then
but you don't have an
but then
expression.
when I did demo 5,
Exactly how it's
and I
done.
loaded up in Sager, it comes up as solution for
Press Enter.
Additional demo.
I think I forgot to say, okay, you write it and you press enter, sorry. More than once.
No, that's the issue with like most of it is like he just copies.
I went through the fucking course last night I was like, I know I'm not doing this incorrectly, forget it. Okay, we're good. Dude, I'm gonna lose the rest of my hair.
Yo, I figured out how to get in your computer. Try it. This is.
Oh, here?
I think I figured it out.
Okay.
Oh, Port A, did you press enter?
Oh, you know what? Actually,
Port A.
I spent way too long on it.
Oh, you have it somewhere.
dude, it's like that.
Oh, you also don't have to do the admin.
So let's type it in.
Yeah.
No, it looks like you were declaring twice.
Blowing my mind right now.
Well, first you need to run the
Legal,
code.
not allowed to not do it, okay.
Yeah, because right now you can't read the new one. Yeah, there you go. Then you right click to change to binary.
I think it's like, probably better if I just did this.
Honestly, just remove the.
If I just did like a new,
Yeah.
Well, you right click on it,
and then just click it, like,
and then you change it to binary.
then there's no way that it can be messed up by, OneDrive.
Yeah, you need to go line by line, right? So that's when you put the breakpoint. Put a breakpoint when you want to stop.
Yeah, because it wasn't even working.
No, I won't.
Put a breakpoint first. That's at the end. You want to you want to see the line by line, put a breakpoint there.
Okay, so you do your.
Okay, so now stop it and run it again.
Corner repository?
Yeah.
Yeah, now it's stopped. Right? So now you
Yeah,
left
okay.
10, you can go line by line.
It's all good.
See how things are.
Okay. Done, okay.
Well, I guess you can press, there's something that says step over.
That's
Press that
where,
button. If your F10.
where are you?
Yeah, if you have laptops with fancy keys that then your F10 doesn't work,
Now,
you can always click on this.
I keep forgetting you need a home repository.
Right.
There's one of these buttons is step over. Yeah, this one. You can click on that one.
Good sign,
Okay?
actually.
Any more questions about this? These, I cannot stress enough how important this is. This is the foundation of the entire course and what comes after this course. If we're not clear about this, nothing else will make sense. Okay? So we gotta make sure we do understand this. We do understand how to set, how to clear, and how to toggle a bit. Okay? And that is in the notes. I know that with the notes, I've been kind of all over the place because I'm not following the sequence that I have in the notes. I apologize for that, but I'm trying to follow a better sequence this time, so you guys can actually understand what's going on. So I'm looking at this now, bitwise operators.
Oh, you do.
And the bitwise operators are described here. The one that we haven't really discussed yet is the NOT, which is this tilde. All this one does is just inverts all the bits. Please do not get confused with this one. This is a logical NOT. So this is just negating a condition, whereas this one is inverting all the bits. Okay? So we haven't yet, we have to do more with this. Of course, we're not going to just do this. It's just, we're just starting, right? And it shows here a bit of a summary of what I was just discussing. Writing a 1 is known as set, like I said. Writing a 0 is known as clear. How do we write a 1 with an OR, right? Now, of course, this bit 5, it's a constant that is defined, see? And we have to, and how do we clear, I guess, yeah, there's a bit more that I have to explain. And the shift operations are here. Okay, so we're gonna go through this in more detail. We're gonna do another demo, but is everything clear with this one so we can go on a break?
Yes.
Can we also do this, sorry, Claire, we said that before.
It'll be the PC.
Yeah, we're also gonna do bit shifting for sure, yeah. I just wanted to introduce these first. But let's take a 10-minute break because this has been
So
a big
it's
drop.
gonna be inside of this file folder here.
Yeah, I want the default to, so then you could also select the in-class demo. And it's gonna save
Yeah, but you're only using the
to,
updates.
that should just clone that repo.
So you're not really using the
name folder.
The channel.
Well, that is why we're using, yeah, that's why we're using timer 6. Because timer 6 has now. Yeah, on purpose, I selected timer 6, so you guys wouldn't try over. So the output compared to or whatever that you're doing there doesn't make any sense with timer 6, because timer 6 doesn't have.
See, I was gonna check it, but I was like, in my head, like, okay, all the time should be at least like have this.
Timers 6 and 7 are very special. And
Oh, instead of having
yeah,
a
and I did explain
Yeah,
that last year,
last
last term, sorry. I said, I wish we had timer 6 and 7, because if we had timer 6 and 7 at that time, I would have started with those timers.
Did you do that?
Because those are the simplest timers that you can
On
have.
this one, is I just.
So they only have the update event, that's it.
So I've got my home folder. Well, actually, I didn't clone the, so on this one specifically, I just cloned the in-class demo repo, separate clone. And then the other one I had set up as like, so,
Well, the prescaler is to set up how fast the timer ticks.
so that's your thing.
How fast it counts. Okay? Because if the timer didn't have any prescaler, it will tick at the rate that the bus speed is. For example, it's at 40 megahertz, then the cycles are 25 milliseconds, so every timer tick will be 25 milliseconds.
Okay.
But that's why you prescale it, so you can tick at a lower rate. And normally the typical rate that we
The only
use
other way
is to
that I
make it tick
kind of aware
at the
of
1 microsecond. Which is why when your
clone the repo.
your bus speed is 40 megahertz, we tend to prescale it by
and
40.
then have that as
So meaning that instead of ticking at 40 megahertz, it ticks at 1 megahertz. So 1 megahertz is 1 microsecond per tick.
So first and foremost, you just divide it by the. Do that, they're gonna be
Yeah.
two completely
Oh,
separate
okay.
files. Okay. That makes a bit more sense. Okay, thank you, sir. That's all. It is,
Not here?
my kryptonite right now.
What's
Oh,
happening?
because probably you just have to
Like, I
go to
don't,
GitHub.
like, so the way this is set up, it shouldn't be two completely
Clone
separate.
the repo that you created or the folder? Where do you put it?
Cause it should just be home and then you go in-class demos and then.
Oh, yes.
That should be where the other demos.
So, yeah, of course, every different machine that you use, you have to put it. So go to the,
It's a supplement, right?
Yeah.
go to your account. and
Oh,
press
that's right.
organizations.
So we're cloning the repo as,
And then go to the
as
top.
like its own named folder as a module, not a submodule.
Okay, and where is your repo then? Scroll down. That's your repo. Click on that one, and you're gonna clone that one. Open.
Oh, no, that's adding it to the GitHub.
Open. Well, you're just gonna put it there, or you're gonna check first? Is that the good location for it?
I actually did this last night and I don't know how.
No, yeah, I did this like over the thing, I was like, okay, that kind of makes more sense. So was the issue like not updating that?
It's not doing a lot of things and never mind.
Okay, So now this bit for my own purposes. Now this repository has a submodule inside which is
Dude, if I have to
so what
fucking
you're
get
gonna do, you're
if
gonna
I have
add
to like,
file.
I might actually get a tutor, pay for them for embedded, just be like, hey, I don't actually need help with embedded, do you need to help me set up my database?
That's not even embedded, that is part of this one.
Inside the repo that you just built.
Okay, let me.
Select the folder. Select folder. That's one add repository. Let's make sure that this thing doesn't show the attached head, so change that to me. Okay, so now if you go to history, you should see all the demos that I pushed. So that's this first one. Oh, there you go. Bitwise demo is here. That's the next one. Yeah, everything is here. Now remember that in the in-class demos is read only. If you want to do something, you gotta put it in your.
Oh, wait, what if we You set the folder as the.
I think on Friday, we're probably gonna start using the board.
This
If
Friday?
not, on Monday. I see one is already posted. I will go over it. If I have time, I'll go over it at the end of the class, otherwise on Friday. Because I gotta show you, how you doing? You have before? No, I'm just asking. I just wanna see that you're doing okay. Are you kind of following or you kind of super lost? Okay, okay. Yeah. Make sure you ask questions because this part is important. Okay? Issues?
I'm gonna pull the rest of my hair out, probably. Like, I'm alright, like literally, it's gonna, it'll be
I'm
gone.
kind of the same as you.
Like,
I just shave.
well, yeah, cause it's easier, I've been too busy to actually shave my head. I am really frustrated. So, what I've done is.
Do one to 27.
This is like a really custom container I'm dealing with. Long story short, I've just created a file folder called git/c. I've avoid all the OneDrive stuff, don't have to worry about it.
Do Jan 27.
I have a feeling I'm doing this incorrectly, so what I've done is I'm going and I'm cloning the repo.
Why is it
I'm
27?
cloning it to this file folder.
The thing is that this shouldn't be here.
That's what Winston was saying.
Yeah, because that repo is already inside your.
Right, so that should be as easy as doing, like coming here, we're gonna remove this, remove it, full remove.
Well, yeah, it depends. It depends if it's already added.
Cause like,
Because that repo will show there. Okay, hold on. No, don't remove it yet.
okay,
So what we're gonna do this. See, hold on.
I keep clicking things.
We're gonna check this repo and we're gonna see where it is located. So repository, show the keyword, it will tell you the local location. So see, this one is in here, in Git. So this is, yeah, we need to erase it. But if it was pointing to this folder,
That
it
would be
will be right.
perfect.
It will be right. But this is not right, so we're gonna remove it. Let's see if we can do that.
Copy the
So what you need to do at this point, you need to go file, add local repository, choose, go inside your repo.
So /c git.
Yeah, you should put it here, well, I guess.
I did that to avoid the OneDrive issue.
In-class demos, because then everybody can see it. That's all.
Oh, I understand.
Add repository, and make sure you get rid of the detached head. And now you see the history, see the
Oh,
white demo.
man.
Now, whenever you are curious and you're saying, oh, did I clone this one outside or is it in the proper location? You always can do the repository, show it here, and now it's pointed to inside this, right? So now it's correct because it's inside this folder.
So all you did.
And by the way, when you go back to your main repository, you do a quick commit here,
Yeah.
just to sync both
Everything up.
repositories.
So you were inside of the home repository. You went repo. No.
No, file, add local repository.
Add local repository, okay.
Then
we
find it
select
inside.
choose, and then this is here, okay,
The
perfect.
problem is that you haven't deleted the other one, and two are gonna show up, and you gotta make sure that later on when you delete one, you delete the right one.
Yeah, which is gonna be the one outside of the
Yeah.
Exit Studio. Okay, so then you selected this, and then we selected this full folder,
Yeah, and then add repository,
add read.
and change the detach head that for some reason shows up always. But the problem you have here now is now that if you click in here, you have two in-class demos. So one of them is right, the other one is not. You gotta delete one of them, and you gotta choose the proper one.
Overcomplicated strikes
It's like when,
again.
you know, always they have this in this movie, when you have someone in a clone or a double of the same person. Who's the right one? And they're gonna kill one of them, right?
Man, we should all just chip in $5, get you to make like a 10-minute video on like how to fix your Git. Put it up on your YouTube channel.
I used to make a bunch of videos, it's just that now, I'm trying to catch up. I gotta make videos for the guys that are.
you have loyal subscribers. Let's check your YouTube, like, no videos?
I don't have my weekly Carlos. Okay, let's see if I can.
Okay, I'm gonna get some water and then we're gonna carry home.
Open in another program. Oh, Sager's open. That's why it's like. I'm gonna go back to Git. That one's inside. Okay, so this is the one that we want. Please give me some Seriously, can't believe it. It doesn't make sense why I would add a local repo and then it works. Like in my brain, like it works. I just don't know why it works.
Also, I don't know how I forgot that. It was literally just like.
You
just
literally
add
all
it.
you did was add.
Sorry, just one more minute.
Yeah, it's there.
Yeah.
File. Add local
Oh, yeah.
add local repository.
And then just choose the
And
path.
then you just chose
The folder itself.
that folder, and then you just did fix your detached
I guess it just doesn't automatically.
Yes.
Cause like we were trying to connect the two,
Well,
right?
does that make sense?
That makes
It's like, it's somewhere on a server, I need to pull into my local drive, to me, that computes.
Same with me, I was just like, why is it not?
So it is doing some, like, there's literal magic happening on the back end.
So basically, what you do is as long as you have the home, right, you just go file,
Add
just
local.
and then you just choose it, let's say,
Wherever the heck it's.
choose your class demo, and then.
Select folder, and then add repo. It'll give you a detached head. Just error. And then you just select from detached head to main, then it's fine.
And then one thing too, make sure to not save anything.
Create a separate folder, and then do your commit.
Yeah, cause like whenever you try to commit, it'll stop you because it's like, you change something, you don't
Now, that being said, I just deleted all of my practice.
More practice, I guess.
That was the beginning.
More, it deletes it.
I wanna go for the intermediate one.
Yeah, you'd have to restore it.
Yeah.
Now we go for the intermediate.
The previous version of Windows, they didn't let you pull into the file folder, retrieve files from it. But if it's stuck in a single file folder, essentially it feels like it's almost like a pre-zip state. So it forces you to restore the entire path before you can access the data.
Three numbers.
I'm gonna try to do some work, but I can't get any progress. Just fuck the shit.
Alright.
Sorry, sir. Just one more minute.
Carlos, can I ask you a question?
Yeah, sure.
Bro, we need to call
But that's you're trying to push or you're trying to pull? You should be able to push.
Yeah, everything's updating, but it's just.
Yeah, that's a good.
Okay.
Yeah, so.
We need Carlos's doppelganger from a different universe, Marlos. Right?
Oh, okay.
500.
So you want. Okay. Yeah. Show you how to do it, you mean? Is that what you mean? Show you guys how to do it?
Yeah.
Yeah. Okay, I'm gonna do that
But actually on board, please.
on the board.
Yeah.
Okay.
Please. Thank you.
That was different to what I did here, right?
Yeah, that's.
Yeah, I'm gonna have to erase this part.
Actually, it could probably be more
I'm
likely
going
that
to erase this one.
his other twin would be like Mateo, like Santiago or something.
Yeah, let's assume that I have my variable declared somewhere here and sign char board A. And I don't know, it's initialized to whatever value. We're gonna do that.
Half of your time is just to eat it.
Okay, so what was the first one?
Set B0.
Set B0. So that would be port A or equals 0B 1, 2, 3, 4, 5, 6, 7, 8. Yeah, what's the next one?
Clear B6.
Clear B6. Port A and 0B 7, 6, 5, 4, 3, 2, 1, 0. Then
Toggle bit 4.
toggle bit 4. Port A, that one would be 7, 6, 5, 4, 3, 2, 1, 0. Three, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Yep.
Bit 4? Yep.
0, 1, 2, 3. 0, 1, 2, 3, 4. Yep. All right.
Yeah, very spacing.
I'm going to create another demo.
Missing out.
It's going to be called Bitwise Demo 2. Very creative name for it.
Super original. Alright, find out if this worked or not.
Well, and here's the thing. Here's a question for you guys.
Huh?
Is anybody already getting sick of these ones and zeros?
Yes.
Yes, right? It's a bit
Thank you,
annoying.
Carl.
For sure.
agrees with me.
Carl was yes, for sure. Well, what if I do this? Hash define
Instead of 5 here.
bit 7
And,
0B1 2, 3, 4, 5, 6, 7, 8. Two, 4, 8. 6, 5, 4. Does anybody already see where I'm going with this?
Oh man.
That's sick, dude.
Well, it takes a bit of work, but what's the key thing here? You only have to do it once.
Interesting.
And then you can copy pasta for every other one of your programs.
Yeah, and in fact, we later on we won't do this. There will be constants already defined for us.
Oh, okay.
Does that make sense? Right? Okay. Then if I said set bit 5, right? I'm using a constant, right?
Yeah.
Clear bit 3.
Bit 3.
Ah, but this one has a trick.
Not bit 3.
Why? Because bit 3 has a 1 only on the bit 3, and I want the opposite. I want a 0 on that one, and once
everything
everywhere
once.
else. That's why where this one becomes relevant, the not. Okay?
Toggle bit 7. This one is an easy one. Oh, bit 7, toggle bit 7 and bit 0. How can you do that? How can I do it in one line? How about that?
And equals?
Or? Why did I think and?
If I OR bit 0 and bit 7, remember, it's a bitwise OR,
Yeah.
then it's going to have a 1 on the bit 7 and a 1 on the bit 0. Right? So that does it. Let's add another one here. Clear bit 4 and bit 2 on the same line. This one is the trickiest one. How can I clear bit 4 and bit 2 on the same line? I know I can clear with this. I know I could do it in 2 lines. That's trivial, right? Now that I know this. But how can I do it in 1 line? I'm gonna do it for you, and you're gonna tell me which theorem that we learned in digital logic I'm using here.
Oh my god. It's gonna De Morgan it.
There we go. Right? Yeah, because if I OR bit 4 and bit 2, I obtain something similar to what I had here. And then if I negate it, I get the inverse of that. And that is actually De Morgan. Because if I do this, this is actually not bit 4 and not bit 2.
I've never heard one word in one course so many times before.
There we go. So now, see, things are starting to make, well, hopefully make more sense, because you have realized that these ones and zeros are good for just, learning the concept, but they're not practical, right? Because it's so easy to make a mistake when you're writing ones and zeros, which is why you normally define these constants. In fact, the micro will have already in the derivative file that we're going to discuss later what it is, it will have constants already defined for you. By all means, you can use these ones. If you want, you can define your own somewhere in your library. And yeah, and the thing is that the micro goes at least all the way up to bit 15, right? So you will have to. I do have a, and now I can go to here, and everything can make more sense when you read these notes. Because I declare this, I did this declaration for this constant. The only difference is the other one is a defined, this one is a const int. It should be actually uint 8 const. But anyways, the only difference is this one is declared in compiling time, during compiling time, whereas the other ones is pre-processing, okay? But they kind of serve the same purpose. And to turn on bit 5, I do it the same way I was doing it in the demo. And to clear bit 5, I do it like this, and to toggle bit 5, I do it like this. Okay? I'm not to that part.
I'm just wondering for resource management purposes, wouldn't we want to define as much as we could before we compile the code to actually run on the
Yeah,
CPU?
yeah, well, that's why these constants in the derivative file, they're normally defined just with hash defined.
Yeah, because then it'll run beforehand, so
Yeah,
it'll just insert
yeah,
where it needs to.
Yeah, so it's very common to do this. So, you could do what I did here, but most likely you won't have to do it because this will be already defined for you. But in your utilities library, you could definitely have something that goes from bit 0 to bit 15 to help you out for whatever reason. Okay? All right. So, somebody asked for a demo with bit shifting, right? So, what I'm gonna do is gonna do another demo. Oh, this was project 5, right?
Technically 6.
Is it?
You're,
Oh,
when you
yeah, this
clicked
is
on
technically 6.
4, or when you
Oh,
click
this
on
is
5, it
five.
comes up as the solution for.
Oh, so it's basically it's a mess.
Yeah.
So this one is supposed to be 6, so I need to fix this thing. Rename, tut, rename, tut.
Yeah.
Then the one prior to this one,
Correct.
copy the name, then open it and fix it. Yeah, normally I do that, but I forget to change it in size, so then it becomes a mess.
I thought I had an issue with my Git repo again.
Yeah.
I have a nightmare.
Okay, so whenever I have that named wrong, you just let me know and I'll fix it. This one I think is right. Is it? Yeah, this one is right. Okay, so I'm going to create now demo. See, I got a bunch of demos. Demo 7, bit shifting. Bit shifting. And I'm going to do something very simple. Let's just open this. And this is going to help you for your assignment as well, but it's already published. You can check it out on Brightspace. Some of you were already checking it. I just got to explain a few things before.
When is it due?
As soon as possible.
So like tomorrow.
So, can I do what I did? Add it in like April?
Well,
Yeah.
you technically can do that. It's just not. It's not going to be practical, right? At that point, because it's going to be too late. You gotta complete your assignments before you write the exam. Right?
Okay, got it.
So you gotta make sure all the assignments are completed prior to the exam, so you're well prepared for the exam.
Got it.
Okay, so I'm going to define an unsigned int, which is going to be how much memory is this going to use? The unsigned int. 4 bytes, right? It's going to be 32 bits. So I'm going to initialize it to, well, let's just, you know what? Let's just define an unsigned short. So it uses only 2 bytes. And I'm going to initialize it as that. Is that correct or not? Why not? This is hexadecimal. And how many bytes is this?
Would that be a negative number?
No, because it's unsigned. It would be actually 65,535.
Wait, so if it was signed, would it be a negative?
Yeah, it would be
Okay.
negative. Yeah, in fact, if we go to our programming calculator, programmer calculator, and then go FFFF, that's 65,535. So it's all ones in binary, okay? And it's 2 bytes. I want to make it on purpose 2 bytes so it's not too big. So then I'm going to do a for loop. From I equals 0, so I less than 16, and then I plus plus. So what I'm going to do each iteration, I'm going to clear 1 bit, and then I'm going to clear the next one, the next one, the next one. I'm going to do bit shift then. Okay? So how can I make sure that, let's explain a little bit what we're doing here. Clear all bits starting, clear all bits 1 by 1 starting from B0 up to B15. Okay, so in the first iteration, I want to clear B0. How can I do that? Number, I clear with an AND, right? And so first I need to identify what it's called a mask, and this is a new concept. A mask is a number that has a 1 on the bit of interest. Okay? So my bit of interest here is going to be to start bit 0. So how about this? 1 bit shifted to the right by I. Okay? So in the first iteration, well, a 1 is just the binary 1, so it's basically a 1. A 1 has a 1 here on the bit 0. Okay? So on the first iteration, the mask is going to be this one. On the second iteration, it's going to be this one. Do we agree? On the third iteration, it's going to be this one.
It would go the opposite way currently. You're bit shifting to the left as opposed to the right currently. Unless I'm not understanding the logic.
Yeah, no, it's shifted to the left. That's correct. So the 1, so the number 1 in binary has a 1 here. Then if I bit shifted to the left by 0, remains on the same spot. If I bit shifted to the left by 1, I put it here. If I shifted by 2, I put it here. So this is a proper way of doing the whole sweep of the mask. All right, but that is just the mask. Now I need to clear the bits. How can I do that? Because that mask has a 1 on the bit of interest, everything else is 0. So I want the opposite, right? Because I want to clear. So I want a 0 on the bit of interest, everything else 1.
We have to invert it somehow.
Yeah.
With the tilde key.
That's exactly what I need to do. And this would effectively do what I want. And why is it giving me an error? Oh, because I'm missing the setting. Okay, so I'm going to test this. For sure, I'm going to run this. I'm going to put a breakpoint here. And I'm going to test this thing. I'm going to add an expression here, which is going to be number. And I'm going, oh, what did I add? Number. Okay, and well, I'm going to particularly show it in binary. So see, it shows F. So I'm going to show it in binary so you can see. I'm going to start pressing F10 like crazy. Look at that.
Cool.
Nice, eh? So that is a way of sweeping through a number bit by bit. Okay? And obviously this can go, I made it simple, 16-bit, but it could also work with a 32-bit number. Okay. Any questions up to this point?
Why would we do it this way as opposed to the first way that you showed us?
Which one was the first one?
So this is bit shifting where we're clearing all the bits bit by bit, whereas in the other method you were just clearing all like
at once?
Yeah.
Oh yeah, well this is just an example to build on top later with what's coming. Yeah, so that was the best I could come up with.
Just trying to understand like why we'd want to do
Yeah,
one or the other.
I know, the example is like, why are we doing this? We're doing this because of where it comes now. So there's one thing that is left here in the notes, which is this part. And it is a concept that we haven't yet discussed, which is masking a bit. What does it mean masking a bit? So we need to go back to the first thing that I was talking, memory. Okay? What happens with this memory? Can be changed by a software, but it can also be changed by a hardware. Right? We should know that at this point. So let's assume that is in this particular bit, let's talk about our port A again. Some particular bit here, this one,
is connected to a switch, to a button. If I press the button and then the pin goes high, this should become a 1. It's now changed by the hardware, not by the software. Okay? This is what embedded systems is about. You can change the resources either with software or hardware.
Gotcha.
Now, we change it with hardware. How does the software know about it?
We need a sniffer.
We need to mask that bit somehow. We need to know if that particular bit is 1 or 0. And how can we know that? With this. So, think about this. This goes back to the very beginning. Any expression different than 0 in C is true, right? When is this going to be true? When the result of this bitwise AND is
Non-zero.
non-zero. Now, we assume at this point, because we define it above, that bit 5 has only a 1 on the bit 5. Everything else is 0. So the only possibility for this to be true is that the port A has a 1 on the bit 5, which will be because somebody pressed the button. So if that happens, this condition is true. If it's not, it's 0, meaning that it's not pressed. Okay? Done.
Why-
Questions?
Why do we have to do something?
Huh?
Are you saying the program does something, or I mean, there's
Yeah, well,
There's logic in there doing
yeah.
stuff.
Well, here's the thing. Later on, I'm going to tell, hey, if you press the button 5, turn on the LED 3, for example. And button 5 is going to be connected to a port, to a bit, and the LED is going to be on the other port, another bit, and so on, and you will be building on top of this. But we need to learn the tools first before we can use them. Here's now the challenge for you. And this is probably the last thing we're going to do just with software. After this, we're moving on to using the board, although we still need to discuss data structures. This is a practical activity. In fact, we could do this also in C#, but it will be a bit different if we do it in C#. In C, it will be more direct. Using the virtual console on Seger, create a simple program that reads a positive integer. So do not enter a negative or a letter because you're going to break the program. But the purpose is not testing validation. Create a program that reads a positive integer from the console and saves it into a 16-bit unsigned int variable. Okay? Well, it says unsigned int, but it should be short int in this case, right? Using bit masking and bit shifting operations, display the number in binary in 16 bits on the debug console. So basically you enter 25, you need to convert that to binary and display it on the console. How are you going to do it? With the tools I just gave you. You just got to think a little bit. Remember, to read a number from the virtual console, you need to use scanf, and to print it, printf with the proper string formatter. Yeah, string formatter is important. Also, you need to make sure that in here you have this enabled. You go right click on the project options and you go to printf, scanf, and you make sure that all these things are enabled, set to yes.
Yeah, can you open
Hmm?
PDF again?
Sorry?
I mean the notes. Can you open the note again?
The OneNote?
Yeah, and scroll up a bit.
This one or the notes on the site?
Yeah, that one.
Oh, okay.
Yeah. So it said if GPIOA and bit 5.
Mm.
So are you not clearing bit 5 down?
I'm not setting clear or toggling. I'm not doing any of those operations. I'm reading, in this case, the ports and masking the bit to know if the port has a 1 on the bit 5. Yeah, this is different. Maybe I threw this too quickly. I know, because I didn't do any example with this.
You really did.
I stepped on the gas. Yeah, but we already know that when we do a bitwise AND, since bit 5
is a mask that I defined that has zeros everywhere except on the bit 5. The only possibility for this operation to be true or non-zero is that this guy has a 1, because 1 and 1 becomes a 1. This mask doesn't care about anything else, right? It cares only about the bit 5.
Now, just to give you a little bit of help with what I gave you, what you're gonna have to do with your number that you receive, you're gonna have to scroll through every single bit using a similar approach to what I just did, and check if the bit is 1 or 0. And if it is 1, print a 1. If it's 0, print a 0. And see how it comes up. And that will be it for today.
Okay.
Thank you so much for your attention. You guys have been great. I like that. Oh, because it's 0x, not 0 star. Yeah, because when you do star, you try to do a multiplication.
Incorrect.
Oh, you've seen that meme of like an old lady that says, "This is my password. It's incorrect. That's incorrect. And it's still
Try again.
Aha. You can't push to that repo. It's read only.
Oh, this is very only.
Yeah, it's read only. So you cannot. If you forget, you're gonna create more issues. You should discard them. Yeah. The in-class demos is just for reading. It's where I push my demos. You can write in your repositories, not inside the in-class demos. You have to put things in a different. Yeah. So you may wanna.
Binary.
Hopefully that can be. Yeah, so you have to do it inside your personal repo, and then you get, oh, and you're in a data sheet. Anyways, go back to your main repo. Now you can, you still have this. Now, how can, no, you cannot push. I just told you that. Okay, so how can we undo this guy?
I straight up thought it was U but that's not like that.
Oh my goodness, you got so much in here. This card more changes. Then I need to know if it's, yeah, you see, undo commits. Discard all changes. I don't know, I'm erasing all the words. But, yeah, no, you cannot push the display. Undo commit, discard all changes. And now you can pull the changes I just pushed. So what you want to do, you want to go to your main repository, your home repository.
What number is for the?
Yeah.
Let's go back.
That's a good.
You can commit this guy.
It's just so
Yeah, well, this is just to have them both in sync. But what you want to do inside this repo is show you the story. You want to create a folder here that is call it practice or whatever. Yeah, and then you can modify those because the in-class demos you cannot modify. This is sort of like a repo inside your repo. And it's read only. Now, why am I overcomplicating things so much? There's a reason for it. Not because I just want to overcome. I do have an answer for that. No, it's not. What would I put it? Like, I want you to do it first. Well, let's try it. Yeah, I will show it maybe next time. Or maybe the. Yeah, because the idea is that you can try it, right? The UN16 requires, where did you get that from? Oh, from here?
Yeah.
Yeah, no, the UN16, UN8 and all that requires an integration of a special library for now, just go uint assign short or something like that. Yeah, sorry, yeah, we, to use what it's on the notes there, we have to include the std-int library. And I will discuss probably that one next class. I even pushed more demos now because I went all the way up to demo 7.
Yes. Oh, never mind.
Should say.
And then the other class is gonna see all these demos. Oh, today is our last class, right? No,
No,
tomorrow.
Friday.
Oh, Friday we'll release the assignment, but you can look at it. I just gotta discuss the pointers to struct, that's the only part.
Wait, structs?
Yeah. But everything else you can start working on.
Well, raise.
What about what?
Oh, I just said a raise.
Arrays, but arrays we saw in C#. You
Yeah.
just need to change the syntax.
Well, wait. What about Carlos? What about libraries?
That comes after. Yeah, we gotta go step by step, and we've been doing very long steps already.
Pretty basic.
Yeah, so.
I know in that one.
No, not even close. I didn't even figure out the math part. You?
No, I'm gonna be sorry.
You haven't even started yet.
Like this, so.
Let's do this Friday.
No, unless you tell me.
Yeah, the due dates put on the assignments are just as a reference. But is an indicator of where you should be at. So if you're late, then you're falling behind, right? That's what you gotta be careful. Can I erase the board? No.